All right, so you guys ready to do this? We're going to keep on going. Number 2. So we're going to start getting into some of these more interesting things that happen here. All right. So we've gone through this one. We've done this one. I remember doing this one. This one was very excited to do. Type errors versus exceptions. Okay, so this is a big thing for me because I love good error handling. Memes aside, thank you for all you do, Prime. Love the content. Hey, Risk Runner, I appreciate that. I genuinely do appreciate that. We're trying to make some good content out here. Alerts stay on during this time because I got to say thank yous. You know what I mean? All right. So let's just do this thing. Hey, thank you. Congrats on 100K. Hey,
I love you.
Thank you. I feel really happy about that.
Welcome to Costco. I love you.
We don't want to be there. Let's go like this. Let's go. What do we call it? I think it was called like hello something. Yeah. There it is. Okay. Let's go utop and let's just throw that in there. This expression has, let's say, has a type string. Okay, good. We can see the error. So how do we do that? The turd, thank you very much. And Neshek, thank you very much for the tier 1s. Can someone explain welcome to Costco meme? Come on. You should know this by now. Idiocracy. One of the greatest movies of all time. Our compile time errors because the plus requires that both arguments type of int. Okay, so this would be a type error. Okay, cool. Love type errors. Whereas errors can't be caught by the type system, like division by 0, lead to runtime exceptions. Okay. Is multiple. Then let's go like this. All right, there we go. So we have that. So we'd go like this. Is a multiple. And then we go like this.
Welcome to Costco.
9-0, right?
I love you.
Should be positive. Okay, so there we go. Yeah. Should be positive. Perfect. Okay, so we did see it. We saw it.
Welcome to Costco.
Okay, so we can do that too. Basher Zombie, thank you very much. And Tuft Pace, thank you for gifting a sub to Ocaml. Appreciate the first gifted sub. Thank you. All right, so let's keep on going. I think we're looking good. Okay, I think we're looking good. Here we go. For you guys, I'll do this just for you guys because, you know, there you go. What does Ocaml stand for? It stands for a lot of things, but mostly functional programming. All right, here we go. So let's see. Let's keep on going right here. This distinction here is that type errors will stop you whether or not the offending code is actually ever executed. Merely defining add potato is an error, whereas is a multiple only fails when it's called. Okay. I wrote an infinite cost abstraction by implementing traits in TS. If anyone's curious.
Welcome to Costco. I love you.
An infinite cost abstraction. Love it. This is beautiful. Hugo, thank you very much. I love this. The O is for functional programming. It is. The O is for functional programming. Tuples list options and pattern matching. Let's go. Okay, so this is the interesting part of Ocaml that I'm very excited about. Tuples. Oh, not tuples though. So far maybe tuples because JavaScript doesn't have tuples, which is very frustrating. It is super frustrating. In Italian dialect, Ocaml literally means the camel. Ocaml. How'd I do? Ocaml. I want to marry you for $5 a month. Awful. Okay. Italian SpongeBob really does not like it. Okay, well, I got an exactly, but Italian SpongeBob. I'm canceling you right now. Borat, that you? Fettuccine. Ocaml. Ocaml. Come on, that's beautiful. Come on, if my fettuccine's correct, then my Ocaml's correct, okay? That's how I determine the correctness of my accents. Anyways, let's keep on going. D's nuts. Thank you for returning the fun to programming, Prime. Hey, thank you. Pronunciation, 100. Twitch Borat, thank you. That's how Italians sound. It's fact. It's fact. When you say fettuccine, that's how they sound. All right, let's see. Here we go. So we'll start by looking at a particular. Okay, so I think we're just fine. A tuple is an order collection of values that can each be a different type. You can create tuples. Okay, yep. There's this. I remember going through this. We kind of looked at this in a different one. Thank you,
Welcome to Costco.
Ocaml's Italian? Apparently. I don't know. For the mathematically inclined, the star is used for the type T because that type corresponds to the set of all pairs containing one value of type T and one of type S. Okay, in other words, it's the Cartesian product. Okay, you can extract the component of tuple using Ocaml's pattern matching. Okay, I think we actually may have gone through this, but who knows? Here, the XY on the left-hand side of the let binding is the pattern. Yes, this pattern lets us mint the new variables x and y, each bound to different components. Yep. Okay, perfect. Note, the same syntax is used for both constructing and for pattern matching. Okay, perfect. Pattern matching can also show up in functional arguments. Here's a function for computing the distance between 2 points. All right, so, oh, nice. Ooh, nice. I think Rust can do the same thing, right? This will be a YouTube video? Yeah. This will be a YouTube video. This will be on the Vimogen. So if you go to YouTube, I have 3 channels. I'm about to drop my first main channel video in a while, but there's the Vimogen, the Prime Timeogen, and the Primeagen. You know what I mean? Ocaml and croissants are French. France's greatest contribution to civilization. Nice. The double star operator is used above for raising a floating point number to the power. Okay, yep. Perfect. Okay, operators in base and the standard lib. Ocaml standard library and base mostly use the same operators for the same things, but there are some differences. For example, in base, star dot is a float exponential and star is integer exponentiation. Whereas in the standard library, star is float exponentiation and integer exponentiation isn't exposed as an operator. Perfect. This is what I'm happy to see. Base does what it does to be consistent with other numerical operators like this and this. Wait, what's star? Oh, star comma. That's just star, not star comma. I was like, star comma? What the hell, star comma? Is that European float numbers? Where the period is the end. Let's see. The period at the end is used to mark the floating point versions. Let's see. In general, base is not shy about presenting different APIs than Ocaml standard library when it's done in the service of consistency and clarity. Classic. A Reason is a programming language powered by Ocaml's strong type system. Wow. Wait until you try Belt. I'm not trying anything else. The EU floats. Yeah, it's real. Where tuples let you combine a fixed number of items, potentially of different types. Lists let you hold any number of the same type. Okay, cool. Note, you can't mix elements of different types in a list. Perfect. Okay, that's fine with me. The list module. Base comes with a list module that has a rich collection of functions for working with lists. We can access values from within a module. Yeah, double semicolon. Double semicolon is like end line. And you use semicolon to separate items in a list, which is... I'm not really sure. Bonjour, monsieur. C'est un plaisir d'apprécier vos compétences en codage. What accent was that? Nobody knows. Nobody knows. You know what I mean? Double semicolons aren't necessary in source code, only in REPL. Oh, no. All right, anyways, let's go like this. So, let's see. It's so you can have... commas for tuples in a list. I'd rather have parentheses. The name, bad pronunciation. The name, not very good at accentogen. Okay? Okay? Why isn't Ocaml more popular? Ooh. Okay, we're gonna have to look at that here in a moment. But let's keep on going with Ocaml first, okay? We're going with Ocaml. Why are you so funny? I find that offensive, okay? What am I, a clown? Am I a clown to you? Am I some sort of clown? I'm trying to, like, get my best Joe Pesci in here. Here's something a little bit more complicated. We can compute the list of lengths of each language as follows. Let's see, list map languages. So this is for F string. Okay, so this is argument F gets string length. Oh, nice. Okay, I get that. Okay, so we take a list function map, pass in our list of languages, then we pass in our mapping function, which happens to be which is a named argument here, as length. Sweet, I love that. Okay, so I'm not going to lie to you. Well, I wouldn't lie to you to begin with, okay? I'm not a liar, okay? I'm not a politician, okay? I'm not here to lie. His voice reminds me of the red-bearded gun-blazing cartoon, and I don't remember the name. Are you talking about... Oh my goodness, I've just forgot his name. My voice sounds nothing like him. pants not. Oh, Yosemite Sam. Yosemite Sam. Yosemite Sam. I prefer Yosemite. All right. So, anyways, you can. Yeah, this is great. I loved named arguments. I like that. Ocaml looks like a toddler smashing on the keyboard. Changed my mind. You have a toddler that's incredible at smashing a keyboard into something that makes coherent sense. I am shocked. The syntax is making more knots in my head. It's just different, right? List map takes two arguments. Yep, a list and a function. Okay. Notably, the function is passed to a list map under the labeled argument f. Labeled arguments are specified by name rather than by position, and thus allow you to change the order in which arguments are presented to a function without changing its behavior. I love that. We'll learn more about that. Okay, perfect. Constructing with lists. French, Spanish languages. Okay. String list, French. Oh, what the hell is this one? In addition to constructing a list using brackets, we can use the list constructor : for adding elements to the front of a list. Well, ¿por qué, Maria? ¿Por qué, Maria? ¿Por qué, Ocaml? Prepend. Okay, so you can double prepend. Okay, here we are creating a new list. Let's see, new and extending list, and not changing the list we started with, as you can see below. Oh, that is a non-mutating change. Okay, cool. ¿Por qué, Maria? Why is Ocaml in there? Why is Ocaml in there? I don't know. Oh, what do you plan to do with Ocaml? I actually plan. Okay, so TJ, Dax, Adam, and I have been talking, and there's a good idea floating around. Okay, let's just say we got a really good idea. You know what I mean? And I'd like to use Ocaml. I like this song as well. Unlike many other languages, Ocaml uses semicolons to separate list elements in a list rather than commas. Commas instead are used for separating elements in a tuple. If you try to use commas in a list, you'll see that your code compiles but doesn't do quite what you might expect. One thing that I will say that makes Ocaml much more appealing right now for me than Rust is just the really great type inference. You know what I mean? You know what I mean? Why not the T in Rust of Go? What does Ocaml solve that the others don't? I want Rust just without all the Rust. You know what I mean? So this would be a tuple. Nice. Okay, perfect. This example's okay. To allocate a tuple of integers, this is generally considered poor style and should be avoided. The bracket notation for lists is really just syntactic sugar for this. Thus, the following declarations are all equivalent. Note that the brackets are used to represent an empty list and that dida is the right associative. Okay, so we got bam, 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 bam. Okay, so these are all equivalent. Interesting. Okay, I'd rather use this, but I guess you could use this. It's just weird to do this at the end, right? So I think I'd rather do that. The double colon constructor can only be used for adding one element to the front of the list with the list terminating at that. An empty list. There's also a list concatenation operator at, which can be used to concatenate two lists. Okay, perfectly fine with me. Odd choice, but whatever. It's important to remember that, unlike double colon, that is not a constant time operation. Concatenating two lists makes time proportional to the length of the list. Okay. In other words, N. We would call that N. By the way, there's one reason why I do like this. Let's see. There's one reason why I like this, and I think people are saying this right here. Well, a better type system than Rust. Why people are saying this? One reason why this is so awesome is that by using different symbols for different operations, right? An @ sign for addition of two lists versus a plus sign for addition of two ints versus a plus dot for an addition of two floats. The reason why that is good is that the type system can infer much quicker, right? There's way more hints about what the types are. So when you do an @ sign between two variables, it can infer all the way up. These must be lists. I'm pretty sure of it. So watch. Here, we'll just try it out. I haven't tried this. Let's just find out. Let add to list. We'll take X and Y and we'll equal and we'll go like this. We'll go X at Y, right? There we go. Look at that. See, it's able to infer because of the syntax. This is a list of, we're not sure what the hell's in there, but they're of the same subtype because we can add the two lists together. I think that's pretty cool, right? I'm in. I'm in on that. You know what I mean? I'm for it. Doesn't that make it more difficult to learn? No. So when it comes to learning, I do not think different syntax for the same thing is harder. It's more annoying than anything else. But if there's a different concept, that's hard to learn, right? So concatenating two lists together, you understand that syntax. It's a matter of, or you understand that the semantics of that. It's about expressing it. And so is this expression harder than any other expression? No. It's really not. Like this isn't like there's nothing to learn here. It's just a different symbol. That's it. Right? And so the expression of it is not hard. List patterns using match. All right, the elements of the list can be accessed through the pattern matching. List patterns are just based on two list constructors. Okay, let's see. My favorite language, this, the rest. Oh, interesting. So this would be my favorite and the rest. This must be the first element and then the rest of the elements? Maybe? Let's see, warning. 8, pattern match. This pattern is not exhaustive. Nice. Ooh, cool. Okay, so look at this. So it does a little bit of pattern matching here. Okay, I bet.
Welcome to Costco.
Okay. That's kind of interesting. I like what's going on here. I like it. By pattern matching using : : Hey, by the way, thank you for Karasik. Let's go. 26 months. Hell yeah. Anyways, by pattern matching using : we've isolated and named the first element of the list, my favorite, and the remaining, the rest. If you know Lisp or Scheme, what we've done is the equivalent of using functions car and CDR. Isn't there like isn't there just some joke about car going forever? Isn't there just like car or something like that? It just keeps on going and getting bigger and bigger and bigger. If I'm not mistaken, to isolate, CAD. It just keeps on growing. To isolate the first element of the list and the remainder of that list. As you can see, however, the top level did not like the definition and split out a warning indicating that pattern is not exhaustive. This means there are values of the type in question that won't be captured by the pattern. The warning even give an example. All right, so super cool. So my favorite language, awesome. This one, failure. Okay, you can avoid these warnings and more importantly, make sure that your code actually handles all possible cases. By the way, this is awesome, by the way. Like, this is a great, pattern matching is one of the things I just do not use a lot to solve problems because I do not get a language that uses pattern matching to solve problems, right? So for the most part, I am required to use TypeScript or C++ or Go. And so I don't get this as an option to really do, but pattern matching seems to be one of the most powerful features of programming languages I have ever seen in my lifetime. And it seems like you can solve a whole host of problems with syntax as opposed to imperative programming or procedural programming. It's like super, super amazing. It brings a whole level of declarative nature to the programming that seems amazing. You know what I mean? TS pattern, I'm not using a library for that. Okay. Can you show an example? Well, we're looking at something right here, plucking the first element off the list, right? So look at that. This is the first element off the list. This is expressed in syntax, right? Like you look at this, this is a declarative nature to this function, which is super cool. So now let's see how they do this. So look at this one. So you can say, my favorite languages, match with language, first, rest, first, nothing, Ocaml, a good default. Like, that's great, right? I like this. I like this a lot, right? Let's see. The preceding code includes our first comment. Ocaml's comments, yeah, that's a weird. They went with a weird choice on this one, but whatever. Can be nested, covering multiple lines. There is no equivalent to C++ style single line quote, blah, 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 blah. First pattern first. The rest covers the case with the languages that have at least one element, since every list except for the empty list can be written down with one or more of these. True. Second pattern matches only the empty list. Awesome. Verified by the compiler. See, this is sweet. I love this. I love that. That solves an entire thing, right? Because how would you write this in? So here, we'll jump back here. So for those that don't know what I'm trying to say, an equivalent of this would be something like this, right? Function, my fave, right, takes in a list. Let's just go like that. And we'd have to do something like this. If list.length equals 0, we return, Ocaml, right? Else we return list 0, right? You could do something like that, or you do something like, what is it? Is it that? Ocaml? I think that's loud. But either way, you have to express it in some sort of way that's imperative, right? It's just different. There's no cases. You can't break it down logically by different ways in which your stuff comes in. You can't shape it as easily. All right. Recursive list functions. Let's go. Recursive functions are functions that call themselves are an important part of working in Ocaml or really any functional language. The typical approach to designing a recursive function is to separate the logic into a set of base cases that can be solved directly and a set of inductive cases where the function breaks the problem down into smaller pieces and then calls itself to solve those problems. So this is just basics. This is literally just the mathematical way to describe this. Awesome. Okay, I'm going to go pee, and then we're going to keep on going. Pee time, and then we're going to go. There we go. While writing recursive list functions, the separation between base cases and inductive cases is often done doing pattern matching. Another beautiful thing. You got chat? Thank you, Lithium. Appreciate that. You didn't do anything. Lithium, what naughty things did you do? Lithium, I knew. Oh, you got chat. Oh, you got chat.
Oh, that scared me.
How did I not see that one coming? How did I not see that coming at all?
I love you.
Oh, goodness gracious. That scared the shit out of me. Okay then. Thank you, Lithium, for the sphincter exercising that just went on. It was the misdirect. It was genuinely the misdirect and your life choices that you've been making recently. Did you pee a little bit more? Just a little bit more. Just enough to make it fun. Okay, for those that aren't on Twitch, that makes no sense. Anyways, let's see. Paisley G, thank you very much. Lithium, thank you. And Randomer, thank you for the Twitch Prime 14 months. I feel like this all day. Just a little bit of pee. Man, the real world Ocaml makes me think of a certain bald guy. I'm not sure with whom the certain bald guy is, but seems exciting. All right, so anyways, let's keep on going. Okay, so match L, nothing here. Head, tail, sum. Okay, yep, and this is the tail recursive version. Boom, boom, boom. I assume that Ocaml does all the good things. We don't actually do stack frames per recursive call. All right, game on. Enjoy your stream. Thank you very much. Following the, let's see, I feel like this all day. Dang. Following this common Ocaml idiom, we use head to refer to head and tail to refer to tail. Note that we had to use rec, a keyword, to allow sum to refer to itself. As you might imagine, the base case and inductive case are different arms of the match. Yes, logically, you can think of the evaluation of a simple recursive functions like sum almost as if we were a mathematical equation whose meaning could unfold by steps. Yeah. Perfect. Yeah. I mean, this is just like an explanation of what recursion is. You're an idiom. I'm an idiom. I love Randy. Lord Dad 69. Let's go. Pokey W. Hell yeah, girl. Pokey W. Let's go. Let's go. 10-month subscriber here. Okay. She pretty much is going to give me her cell phone number at any moment. Okay. Because, like, obviously, big fan. Obviously, big fan. I hate when languages call themselves, call the same shit by different names. Yeah, Ocaml jokes are better than cock jokes. Yeah, I think so. All right, remove sequential duplicate list. Match this first, second, tail. If first equals second, then remove sequential duplicates second. It's beautiful. Let's see. Hold on. This pattern matching is not... Okay, what is this? We can introduce more complicated list patterns as well. Here's a function removing sequential duplicates. Okay, I can understand why this doesn't work. I think I understand why this doesn't work, which is, what about a list of one? A list of one does not have two individual items in it. So is that the thing? Yeah, there we go. Called it. Okay, called it. Not long enough. I mean, I've been called that so many times myself that it actually, like, I can just see it, right? I can just see it right away. The moment something is not long enough, I just know, because I've had just such an extensive journey being there. I want to thank you because you saved my life. I have ADHD, and I was taking medications that were making me anxious and antisocial. Dang. That's tough. Not long enough, I know. Maple Leaf? You're learning a nerd language?
I love
Hell
you.
yeah, Maple Leaf. How you doing, by the way, Mapes, McGrapes? Haven't seen you in a while. Ever since I called you Andrew Mapes, I feel like you haven't stopped by. I have no idea why. Are you okay? Yeah, you said something about on the Twitters that you just want to program more and you're tired of bullshit. So, hey, more power to you. Hell yeah, Prime for Prime. Hey, thank you very much. Appreciate that, Greater Dispel. First DQ size. You're not allowed to name the anime girl avatar. Yeah, I know. Is a functional programming language the other way of programming, or does it provide? It doesn't provide performance. Usually they're slower. They tend to be slower as far as I can tell. But I don't think that's always true. All right, note that this code used another variant of the list pattern, head, to match a list with a single element. We can do this to match a list with any fixed number of elements. For example, XYZ will match any list with exactly 3 elements and bind those elements to the variables. I wonder how that works. Ocaml is just recursion, switch statements, and pipes. Yeah. In the last few examples, our list processing code involved a lot of recursive functions practice. Okay, options. Let's go through options. Okay, so there is some. Okay. Oh, okay. So this would be safe divide. Of course, speed is the only thing that matters in programming. Hell yeah, girl. That's why I'm the fastest slay in the West, okay? Because speed matters. Hey, chat, does a streamer know purely functional language? No, I know nothing.
It turns all your bad
that is why I'm reading. I know nothing. The Bifrost. The Bifrost. Thank you very much. I know nothing of. This is my first functional programming language. The function divide either returns none if the divisor is 0 or sum if the result of the division otherwise. Okay, perfect. Let's see. To examine the contents of an option, we use pattern matching. Okay, cool. Okay, so how do we do that? None, sum. Okay. Okay, cool. Okay, this all makes sense. So I'm starting to speed through because I don't want to keep on. You know what I mean? I don't want to keep on going forever here. I want to, Haskell has to be your next to learn. No, I'm not learning Haskell. Okay, I shipped Haskell to prod already this morning. Can confirm. Added so many operators just to confuse coworkers. Added some extra math too. Nice. Some lambda calculus. You talked about some monads or some shit. Note that we use the operator for concatenating strings. Okay. Are you done with Zig? Friendship over with Zig. Didn't you see that? Obviously, C++ is my new love. Okay. This is my new love. I only love C++. Okay? I only love C++. Okay? Go ahead. Say something stupid. Double stuffed tacos based. Thank you. Can you still see that you... Wait, what? I stared at Haskell once. Okay, thank you. Hey, thank you for pinning it. I don't understand. Get the flamer. Yep. Yeah. Template, type name. Okay, that's just rude. We don't bring that up, okay? All right. Did you know you can watch other... Let's see. Do you watch other streamers too? Tej, Dax, etc.? No, I don't really watch streams. I stop by to say hi.
It turns all your bad feelings into
because I like people.
Feelings.
Thank you, dude. Okay, well, Brian Frost. Okay, thank you for the 2 in a row. Big time thank yous. I don't watch other streams.
Welcome to Costco.
I'm not a big...
I love you.
It's hard for me because I have to be like so in the zone. You know what I mean? I have to be so in the zone. I'm a manager? No. I'm an IC, baby. I would be... No, I don't watch any... I just said I don't watch anybody. If I'm... Like, I will put TJ on sometimes in the background just so I can chat with TJ every now and then. Like I said, either I'm going to be... Here's how it goes. We're going straight to Excali draw for this.
Welcome to Costco. I love you.
It's very, very simple. It's very, very simple, okay? Here is my life. Okay? There's, like, C-suite, right? There is E-suite. There are... This is like a typical company. There are directors. This is like typical company hierarchy, right? There are managers. And there's variations of all these, right? E-suite, C-suite, senior, this, and IC, right? So here you go. Here's the variation of what is available. I will literally never try to be one of these two. I will only accept this area. I am not good. I'm not that person, right? I'm just never going to be that person. You know what I mean? I'm just not. You know, all the way. I'm all the way down. Have you forgotten the G spot? That doesn't exist. We all know that. I want to be at the top of the bottom of the pile. Exactly. So you're a bottom. I'm a bottom. Either I'm a top or I'm a bottom. I'm not a middle out. Okay. There's no efficiency here. I'm not rowing the boat, as they say. Right. This is how you row a boat. Right. There's no rowing the boat around here. Is that what they say? Do engineering managers at Netflix earn more than individual ICs? I heard no from multiple managers. I've asked because I was like, I hear it changes once you get to director level. But I don't want to do that even for the monies. You know what I mean? If someone offered me to do a director at Netflix, I wouldn't want to do that. You're a head or a tail, not top or bottom. That's right. I'm a head or a tail, baby. So there you go. Too many letters. Grug is scared. Exactly. What is IC? Individual contributor. Am I the only one that don't get this IC C E-Suite? E-Suite's VPs. C-Suite is Chief Star Officer. Fine, Director of Memes will have to be somebody else. You know that's a Vice President of Memes, okay? Anyways, here we go. There we go. IC equals I can't. Chef Suite. Yes. All right, anyways. Let's see. Hold on. Options are important because they are the standard way in Ocaml to encode a value that might not be there. There's no such thing as a null pointer exception in Ocaml. This is different than from most languages, including Java and C#, where most, if not all, the data are nullable, meaning that whenever their type is any given value, that also contains the possibility of being a null value. Yep. That is why there's nothing worse when someone in TypeScript has this value. I hate that. When someone comes dropping in TypeScript, giving me that bullshit, that is bullshit. You will not hand me a nullable Boolean. I don't want tri-state, okay? You give me a true, you give me a false, you don't give me a tri-state. The end. Okay? The end. Boolean. I call Boolean. Boolean. Anyways, let's see. Point 2D is a record type. Okay, so I don't know much about records. Right? Hold on. Are we there yet? We're at records. Okay. Hold on. Are we at records? Okay, options. We've done options, so let's go to record and variant. So far, we've only looked at data structures that were predefined in the language, like lists and tuples. Hey, thank you very much. I love you too. But Ocaml allows you to define new data types. Okay, this is what I wanted to see. Here's a toy example of data types representing a point in two-dimensional space. Okay, type point equals this. Sweet. Point 2D is a record type, which you can think of like a tuple where the individual fields are named rather than being defined positionally. Record types are easy enough to construct. Yes. Ooh, that's beautiful. Love it. Love the syntax. Okay. Woo! We can access these elements with pattern matching. Let's go. Love it. Okay. Oh, a floating squirt. Nothing's better than a floating squirt. You know what I mean? The pattern match here binds the variable x position. Yep. Okay. Can you just access them with the dot separator? Or do you always have to pattern match them out? Alternative, we can use dot notation for records. Perfect. Love it. We can of course include our newly defined types as components in larger types. Nice. Okay. Good. I'm all about that float squirt. So that means we can have some sort of function. Let foo x equals x dot foo foo. There we go. Right? Unbound record field foo-foo. Okay, so why doesn't that work? Do I have to first do this one? Was that the syntax? Let's see. Type. No, they use there we go. Uh-oh. What the hell? All right, there we go. Syntax error.
Welcome to Costco. I love you.
Oh, can I not use capital letters? Oh. Strange, but okay. What about now? Okay, so since... Oh, cool. 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 You see that? I can't define this function because this type never existed. Why did you pause my music, YouTube? Let's restart this song because it's kind of a banger. I'm kind of liking it. You know what I mean? That was cool. That was cool that the type, you can't make a function that can't accept a type that's not already in scope. Love it. If a type isn't in scope, IG different module, you need to open that module locally. Yeah. It paused on what kind of programming do you like, Prime? The technical kind. No anonymous records? No anonymous records, apparently. But I assume it does. I wonder if there must be like an interface record or some way to, types are always explicit. There must be some sort of animal dog thing going on, right? Explicit. Okay,
Welcome to
Wax60. Thank you for the tier 1 3 months. Let's go. Let's go. Point 2D is a record type. Okay, wait. We already looked at that. Float squirt me, daddy. Wow. No, my wife might hear that. Shut up. Max Zawisi. How's Ocaml? It's going good. It is going good. Now I imagine that you want to combine multiple objects of these types together as a description of a multi-object scene. You need some undefined way of representing those objects together in a single type. Variant types let you do just that. Okay. Oh, nice. Variant types. Okay, so these are variant types. I assume this is the exact same thing as saying a tagged union. Is this effectively a tagged union, right? Music interrupted when I clicked your video. YouTube knows everything, I know. The pipe character separates the different cases of the variant. Cool. The first is optional. And each use case has a capital tag like circle, rectum, and segment to distinguish that case from the others. Awesome. Here's how we might write the function for testing whether a point is in the interior of some element of the scene elements. Okay, this is too much. Okay, that's way too much math. First off, I'd just like to say I'm sorry or congratulations. Really amazing stuff. But I do see that we do use the rectum, the circle, and the segment here. And then we call some sort of exists business. Inside scene, point, scene, list, scenes, function, inside point. And it does some sort of magic. So I don't know what the hell's happening there, okay? I was told that Ocaml didn't do math. Well, apparently I'm doing math, and I'm not sure if I like this. Okay, you might at this point notice that we use match here is reminiscent of how we use match with options and list. There is no accident. Option and list are just examples of variant types that are almost enough to be defined in the standard library. Almost. And in this case of list, let's see, to have some special syntax. Okay. We also have made our first use of anonymous function. Okay. Yeah. What does that look like? Fun. Okay. So if you just do fun, that's anonymous function. Cool. All right. Based and polymorphic comparison. You know what? We're getting based and polymorphic here, boys. Let's go. Let's go. I can't wait. All right, one thing to notice was the fact that we opened float 0 in the definition of inside scene element. That allowed us to use the simple undotted infix operators. But more importantly, it brought the float comparison operators into scope. When using base, the default comparison operators work only on integers. If you need to explicitly choose other comparison operators when you want them, Ocaml also offers a special set of polymorphic comparison operators that can work on almost any type, but those are considered to be problematic. Agreed. I actually love the fact that there's different things for every type. I like it. Whoopsies. Didn't mean to click that. Go back. And so are hidden by default by base. We'll learn more about polymorphic compare in Chapter 3, terser and faster patterns. Let's go. Thank you very much. Polymorphism. Hey, Brifost. Thank you. The Bryfost. All right. On. So, let's see. Let open with float 0. And so that means these are float operators? Are these supposed to be float? Is that what they're saying? Okay, so because lower x, what is that? That's a lower x. Yeah, lower those. So these are all floats. So by doing this float open, these became floats. Is that how the plus operator works? Is that what happened? Am I saying this correct? Since we opened float 0, where are you? Sorry, I don't know why I'm not looking at my screen. That actually is the equivalent of. Right, of plus dot, right? It brought the float operators into lexical scope. Nice. Okay, so that's why you do these kind of let open ins. Okay. Yeah. Okay. Imperative programming. The code we've written so far has almost been entirely pure or functional, which roughly speaking means the code in question doesn't modify variables or values or get you a day job as part of its execution. Indeed, almost all of the data structures we've encountered are immutable, meaning there is no way in the language to modify them at all. This is quite different style from imperative programming, where computations are structured as a sequence of instructions that operate by making modifications to the state of the program. Functional code is the default in Ocaml, with variable bindings and most data structures being immutable. But Ocaml also has excellent support for imperative programming, including mutable data structures like arrays and hash tables, and control flow structs like for and while. I love that. This is great because like arrays are just fast, right? We just got done watching a video about how fast arrays are. Again, sounds pragmatic, but this is like the whole Ocaml thing. As far as I can tell, Ocaml is like if a bunch of academics had to get a real job and then used all their brain power to build something that you could actually get something done with. I'm very excited about Ocaml. Okay, I know that's very insulting to my Haskellers out there, but hey, you know what I mean? You know what I mean? All right, arrays. Arrays are the simplest mutable data structure in Ocaml is the array. Arrays, I added the word array somewhere in there. Sorry, Pick. Sorry, Pick. Please don't hate me. Arrays in Ocaml are very similar to arrays in other languages like C. Indexing starts at 0 and if it started at 1, I might just give up right now. And accessing or modifying an array element is a constant time operation. Arrays are more compact in terms of memory utilization than most other data structures in Ocaml, including lists. Here's an example. Oh, you gotta do little barsies. Hell yeah, girl, let's do a bar. Okay. This is some weird, I'm not sure what I'm looking at. Okay, the .i syntax is used to refer to an element inside the array, and the arrow syntax is for modification. Damn, that's gonna be hard to remember. Okay, that's mutable assignment. Shipped more Haskell to prod. Totally academic. LOL. Sounds like such a Haskeller comment. Well, actually, I did ship code to production. Loser. Happened. Okay. The unit type we've seen as the preceding code is interesting in that it only has one possible value, this, which means that the value of the type unit doesn't convey any information and so generally is used as a placeholder. Thus, we use unit for the return value. I'm sorry, dude, I'm roasting chat. Sorry, chat. Chat, sorry. Okay? For all my Haskellers out there, except Pick, I think you guys are wonderful and great. Nothing against you guys at all, okay? You guys are you're fantastic. Why does it keep becoming dark, Karen? But real talk, Karen, I need you to immediately reach out to Pick and send him yet another bottle of my signature coconut oil, pre-used. You know what I mean? He'll rub that all over his feet or some weird shit. I don't know. Pre-used coconut oil. Pretty excited about that, huh? It's actually my upcoming brand deal. What I do is I cover myself in coconut oil, head to toe, like thick. Okay, we put it on thick. I look like Casper at this point. Okay, that's how thick it is. Then what I do is I go stand in a hot room and it drips down my body to my toes, and I happen to be standing on a series of mason jars. Okay. Full body. Full exposure. Ew, what? Full. Oh, yeah. You get some sausage oil in there. I'm just saying. Like Gamer Girl bathwater, just like Gamer Girl bathwater or that other girl's fart jar air. If you've seen that one. If you haven't seen that one, you're a loser. Also, girl who were selling fart jar air also had to go to the hospital due to some problem. My guess is that she was trying to eat highly fartable air food.
Welcome to
Cause
Costco.
some sort of internal
love you.
combustion that was inappropriate. You know what I mean? Dusky, thank you very much. I appreciate it. Just joined the stream. So glad I joined. Hey, welcome. Welcome to the stream. Prime coconut water, absolutely. Okay, hold on. Here we go. So let's get back into here. Okay. Mutable record fields. The array is an important mutable data structure, but it's not the only one. Records which are immutable by default can have some of their fields explicitly declared as mutable. Oh, cool. Explicitly individual fields declared as mutable. Love it. Here's an example of mutable data structures for storing running statistical summary of a collection of numbers. Okay, so you can go mutable sum. Beautiful. The fields in running sum are designed to be easy to extend incrementally and sufficient to compute means the standard deviation as shown in the following example. Don't compute the standard deviation. No one knows how that works, okay? Variance, summing, and shit. The R sum equals R sum float, R sum samples. Okay. Mean, okay. Standard deviation equals all this stuff. Nobody knows what is going on there, okay? Okay, nobody knows. Okay, so cool. Let's see. We also need functions to create and update running squares. Okay, create. It does this one. Or running sums, not squares. Okay, update. All right. Okay, then we do samples over. Oh, interesting. I've never liked I've never liked white space aligned assignments like this. I've always found that gross. Do you guys find that gross? I've always found that gross. Right? I've never liked that. I don't like to have to like read so far over, right? There's a lot of white space, and I get all confused and stuff. Yeah, like in Go, it's actually so one of the reasons that I hate it in Go is that they make you do that, and then I get really confused at my fields. Yeah, normally we don't do that in Ocaml. Okay. Create, return a running sum corresponding to an empty set, and update our sum x changes. So that must be what you're doing. X must be the sample, right? So we get one more sample. The sum is this, plus equals this. The sum squared equals this, plus. Okay, awesome. Cool. Note, the use of single semicolons to sequence operations. When we're working purely functionally, this wasn't necessary. But when you start needing it, you need to do it with imperative code. Okay, so there are single semicolons are for like putting statements, but not ending the thing. Okay, so this is the function. It has statement 1, statement 2, statement 3, and it's done. Okay. Note the use of, yes, let's see. Here's an example to create an update in action. Note that this code uses list iter, which calls the function f. Okay, cool. All right, so list iter, go through here, function this, update. Awesome. Love to see it. Warning, the preceding algorithm is numerically naive and has poor precision in the presence of many values that cancel each other out. The Wikipedia article on algorithms for calculating variance provide much more detail. Okay. Refs. We can create single mutable value by using a ref. Love this. Okay, a ref value or ref type comes. Dude, this is so good. Real talk, like this is so good because this may not mean a lot to you, but the fact that they give you escape hatches to do the right, like to do the better thing, to make like immutability isn't great. Immutability is a tool to simplify how you view the world. But being able to just be like, that, let's just mutate everything in this one special area because we just got to go fast, and they just give you everything. I love this. This is great. All right, so const this, let x equals this. It's a ref to contents. Contents this. All right. It's an int ref. By using a ref. The ref type comes predefined in the standard library, but there's nothing really special about it. Okay, good. There's a handful of useful functions and operators defined for refs to make more convenient work. All right, ref 0, create a reference. Nice. Let's see, it gets the contents of a ref. Oh. Okay. I see you. Ocaml. Strange syntax. This is kind of strange syntax. My brain has a really hard time with the bang. I'm not going to lie to you. I'm not gonna lie to you. That guy, it hurts me. We're banging refs out here, and I'm not sure if that's legal or not. There's nothing magical with these operators either. You can completely re-implement the ref type and all these operations in just a few lines of code. Okay, type A ref equals mutable contents A. Type A ref equals mutable contents A. Cool. Let's see. Let ref X equals contents X. Okay. Let bang. Oh my goodness, you just defined an operator. Okay, love it. Love it. Let colon equals RX equals contents goes into this one. Oh my goodness. This is cool. Are you sure you love it? I think I love it. I think I love it other than the fact that I hate operator overloading. The tick A before the ref indicates a ref type is polymorphic in the same way that lists are polymorphic, meaning it can contain values of any type, but it's of a specific type. Yeah. Just like any in Go, which is cool. I like that they used any properly in Go. The parentheses around bang and that are needed because these operators rather than ordinary functions. Okay. Even though a ref is just another record type, it's important because it's the standard way of simulating the traditional mutable variables you'll find in most languages. For example, we can sum over elements of a list imperatively by calling list iter to call a simple function on every... Okay, let's see it. Sum list. Let sum ref 0 in this list iter function. Okay, so this would be like avoiding a reduce, right? Is this what you do to avoid a reduce? Right? So I could make the 8 is equivalent to D operator. Very excited. Very excited. We're going to make the longest 8 is equivalent to D operator in Haskell. We're going to do it. Suddenly, Rust seems easy. Well... We'll see. Nesting lets with let and in. Yep, the definition of sum in the above example was our first use of let to define a new variable within the body of a function. A let paired with in can be used to introduce new bindings within any local scope, yep, including a function body. The in marks the beginning of the scope. Yep, this makes sense. So this only lasts until this thing right here. So Z only exists for this scope, which is cool. Note that the scope of the let binding is terminated by the double semicolon. I love this. This is cool. I love being able to scope things even smaller than, say, a function. It's cool. It's a cool thing. We can also have multiple let bindings in a row. Yep, so they only exist within this region. I think that is super cool. Does the new syntax gets captured by the LSP? I assume that the LSP is good. Ocaml seems to have really good tooling. As far as I can tell, it's really good tooling. For and while loops. Ocaml also supports traditional imperative control flow constructs like for and while. Okay, awesome. For length. For I equals 0 to length minus 2, do this thing. Done. Okay, very bashy. Permute array. Let length in length of array in this. For length this. Random int this. I see what happened here. Okay, cool. Has someone made an Ocaml case joke yet? I don't think so. Here's the example of this code. Okay, let's see. Hold on. This is our first use of random module. Note that random starts with a fixed seed. Yeah, hey, good luck using random numbers in Rust. But you can call random self init to choose a new seed. Okay. From the syntactic perspective, you should note the keywords that distinguish a for loop and a for to do and done. Here's an example code. Okay, let's see. Here we go. Our array init 20 function fi for I. Okay, so this must be a size. Give me an array size 20. Yep, there it goes. Size 20. Oh, beautiful. It can do us. Oh, I love that. And the pseudo random actually, dev random actually. Ocaml also supports while loops. Okay. While position is less than array, a length array. And array.position is greater than or equal to 0. Okay, so this would be an array of references. No, never mind. Position's the reference. Yeah, that's right. That's right. So, okay, cool. If position is equal to the array length, then none, else some. Okay, perfect. Find first. Nice. Okay, this is cool. I understand this. I can read Ocaml. I know Kung Fu. All right. As a side note, the preceding code takes advantage of the fact that Ocaml's AND operator short circuits. In particular, an expression with will only evaluate expression 1 if expression 1. Yep. This is just true in pretty much all languages. Indeed, we can trigger the out of bounds error by rewriting our function to avoid some short circuiting.
Welcome to Costco.
Yeah, we don't have to worry about that. Hey, welcome to Costco. I love you. Thank you very much, Pirate Muncher. Let's see that, Kung Fu King. Well, I want to keep on going. Okay, a complete program. Okay. All right, let's try this thing out. So far, we've played with the basic features of the language via UTOP. Now, we'll show how to create a simple standalone program. In particular, we'll create a program that sums up a list of numbers read in from the standard input. Here's the code. In which you can save in a file called. So I really wish they would walk you through right here. So if anyone's listening, because I know some people on Twitter were talking up that were actually a part of making this, were saying, hey, they appreciate me going through this. But this right here, I find very, very important. I wish they would have just showed you how to create the project here, because I honestly don't even know where to put anything, right? Like, where the hell do I put some ML? I don't even know. I don't know how to create a project yet. You know what I mean? All right. Ah, crap. All right, so we're here. I assume, okay. What did I call my thing? So this is what I don't know. It's called Hello World, and I assume libdune says there's a library named Hello World, so we don't want that, right? We want an executable. Is that what we want? So would I go like this? So would I go here? Can I add more? Can I say an executable? It should be named sum? See, I don't even know. Sum.ml? Is that what they're asking me to do? I have too many NeoVims open. Let's close this one. Dune build. No, module sum is used in several stanzas. Okay. Let's see. To fix this error, you must specify an explicit modules field in every library, executable and executables stanza in this Dune file. Note that each module cannot appear in more than one modules field. It must belong to a single library or executable. I don't even know what that's. I don't even know what that means. Okay. What the hell does that even mean? What the hell is main? Why is it in bin? So that's another thing I don't understand is how to like organize an Ocaml project, right? Like I don't even know how to do a Hello World yet. That's how stupid I am. So we're gonna go like this. Personal.
Welcome to Costco.
Hey.
I love you.
Thank you very much. Whoop whoop. Appreciate that. One Dune, one lib executable, maybe. I don't know. I don't know yet. Okay. We're gonna go like this. Dune init project. We're going to do a project, and we're going to call this some me daddy. All right, so it's a library. I don't understand that. Do I say executable if I wanted an executable? Docs, explain it, lad. Well, I'm just trying to go through this, okay? Docs, explain it, son. I'm going through a tutorial, okay? A tutorial. Use the bin directory. All executables are in the bin. Oh, really? Let's see, hold on. First, we need to write a Dune project file specific to the root directory. See, you should start with this first. Nice. Okay, so cool. Okay, so let's go to that last. So let's try to do this, I guess, without doing a Dune project. RMRF sum me daddy. Make dir sum me daddy. CD sum me daddy. All right, so I'm gonna do this. We need to create a Dune project file. Dune project file, and that looks like some sort of Lispy scheme. Lang Dune. 2.9. Okay, and what's the other one? Name RWO example? What the hell does that even mean? Real world Ocaml. Got it, first try. I'm a genius. I'm an effing genius. I am an effing genius, okay? Then we need to write a Dune file to specify the specific thing being built. Note that a single project will just have one Dune project file, but potentially many subdirectories with different Dune files. Okay, in this case, however, we just have one. Executable, name, libraries. Oh, fun. Okay, so I assume I can just do a Dune right here then? All right, there we go. And I assume this also means I do a sum ML, right? Now we invoke the build. Let's see, all we need to specify is the fact that we're building an executable rather than a library, the name of the executable, and the libraries we depend on. Cool. So I'd go Dune build. Okay, so I did build it. Okay, so there we go. So we have that. So let's go back up here. So how do I do that? So I guess we're going open base, and we're doing, no, we don't do that afterwards. Open standard lib. Oh, we're poning libs now, boys. We're poning the libs. Whoa, what's this? See, this, okay, so I don't quite get this one. We'll come back to that. We'll come back to looking at that.
Welcome to Costco.
I know what's going on.
I love you.
The thing I don't know what to do is I need to go to Mason because I'm just using Mason right now. I'm trying a year of Mason, where I just install this one. This one obviously takes just whatever the latest one is, and by taking the latest one, I'm getting something that isn't for 4.14. I'm getting 5.0, right? And so that means I need to somehow specify somewhere this is the version I need. You know what I mean? I don't use Ocaml. Yeah, see, that's the problem. That's why I got it. We'll look at it later. Okay, I'm not too worried about that. That's just get my stuff. Okay, so we're gonna do some sort of let rec read in stream, right? Equals, right? So let's see what we got. We gotta have an accumulator, right? Ooh, we have an accumulator. Interesting. Okay, is that a ref accumulator? No, it's not a ref. Let's see. Let line equals in channel input line in channel standard in. Okay. That seems nice. So we go like this. Let line equals input channel. Input line. Yes. Input line. Okay. Yeah. And then what do we put here? Okay. Okay, so it is this thing. That is the one we're referring to. Okay. Nice. Thank you, Copilot, for being correct. What do we do here? We're going to match line with this. Either we have something or we have nothing. So we're going to go read and accumulate. Oh, we're going to call ourselves with the new one. Oh, nice. Okay, so we either have none, which just returns the accumulator, or we have, is it sum x? Yep, sum x. And this one, we're going to keep on doing the whole read in stream. Yep. Except for we're not going to add it as a list. We're going to want to do float. Let's see, we're going to want to do accum plus as a float, right? We're plussing as a float. And then we're going to want the float let's see, of string x. Yeah, I think that's right. Then do we just hit it right there as the ending? Oh, you don't even need to do the double semicolon. Interesting. I kind of like the double semicolon. You know what I mean? All right, so then we have a no function one. So we're going to do this. Then we're going to read and accumulate 0. Okay. Interesting. Why do we have to do a function here? So why do we have to do a function here? I don't understand why we do a function. Why can't we just go this? Right? Why can't we just do that? Like, why do we have to do a function of nothing? And who invokes that? I don't get that. What does that mean? This is not a function. Oh. Let is like the main function. Oh. It's the entry point. Okay. Okay. So why didn't they just use main? I'm sure that's a stupid question. You don't have to answer that question. You're pattern matching the to normie. Yeah, I don't know what that means. I honestly don't know what that means yet, but okay. So if I put this somewhere, this executes. So why would people do that versus this? Like, why not just that? What's the point of doing that? All right, unbound module input channel. Do you mean in channel? Ooh, did I write that wrong? Is it in channel? Oh, it is in channel, isn't it? All right, printf. Unbound value printf. Oh man, is this that weird thing? I feel like there's like something weird about all this. I feel like I've been here before, but I don't know why. You just got a Netflix ad. You wanted IO? Oh, I did. Oh, okay. Okay. Dune, can you just do you do what do you do? How do you run this? How do you run this son of a bitch? Dune exact. Why do I have to have an exe? Dune build some. Can I just say some? Damn it! I have to have an exe. Okay, so there is that one. So then, do I just do Dune run to run it? Do I go build default some exe 45 24? It was 69. Okay. You don't need that? Well, then why didn't it work, tough guy? 45, 24, kill the program. Okay, well, how the hell do I give it a num? How do I give it none? I'm trying to end this. I'm trying to end this thing. Oh, we probably have to give it an end of file. So I'm going to want to go like this. I'm going to want to go vim nums 45, 24. Don't give it that new line. You know what I'm talking about? And we'll just go cat nums, pipe that. Oh, control D is end of file. Yeah, of course, that makes sense. Gosh. Genius. I always forget about that. 45, 24. Got him. Okay. My first program. Rookie mistake. Just straight rookie. Compiling and running. Okay, yep, we've done all this. All right, where to go from here? That is our guided tour. There are plenty of features left and lots of details to explain, but we hope you now have a sense of what to expect from Ocaml. I feel like I need... today I learned Control D.
Welcome
you
to
got to know the D.
Costco.
Okay, I forgot about the D, but you got to know about the D. Well, this was great. I feel like I'm in a position now where I want to learn more Ocaml. Do you know what I mean?